Now that you've had a little practice on finding the determinants of 2 by 2 matrices, we are ready to move on with finding the determinant of a 3 by 3 matrix. Now that becomes a little bit more interesting. I will tell you that a formula does exist. However, I found that it's a bit hard to memorize with all the subscripts and all the types of different, products that you would have to make. So we have this technique called expansion by minors. That allows us to break up a 3 by 3 determinant into a sum and difference of a few 2 by 2 determinants. And the 2 by 2 determinants are quite nice because we could quickly calculate them. Their formula is not so bad for us to work with. So you'll notice that the directions on this example, they're actually being specific. They're asking us to evaluate the following determinant by expanding by the third column. So you kind of think about what the third column is. We have -1, 4, and 6. So before we start, I'm going to look at my corresponding array of signs and also kind of compare that so I can help you with this. So just kind of bear with me for a second. If you have a corresponding array of signs, which kind of helps us out with the formula, it always starts with the top left element, or what is it? A sub 1, 1, row 1, column 1, is a plus sign. And from there, what you will do is you will alternate the signs to help you out. So if we can do that together. If we're looking at trying to make corresponding signs, we have 3 elements in the first row, so plus, minus, plus. Then we're alternating signs, so the second row, first column should start with a minus, then we alternate plus, minus. And then the third row, first column, we're alternating, so we have a plus, minus, and plus. And so kind of keep in mind that the array of signs matches the dimensions of your original determinant. So now what I'd like to do is look at the corresponding column that they're asking us to expand by in the array of signs. So you see we have a plus, minus, plus. So as we expand by minors, if I'm looking at what the determinant should be, the first step I will do for myself is write out the elements in the third column, and I'm going to space them out a bit. So we're going to look at -1, 4, and 6. And while I'm doing this, I'm keeping in mind that there will be 2 by 2 determinants that I have to multiply by all of these elements. But before I get there, what I'd like to show you is that we will have to deal with the signs first. So along with the third column of the original matrix that they're giving us, we're looking at the third column of the array of signs. And so we will match each of the signs with their corresponding element. So if you look at the top right corner, that's row 1, column 3, that should match up with the -1. So technically we're going to multiply those signs by whatever the sign of the original element was. The second row, third column is a negative sign, so that's going to get multiplied by a +4. And the third row, third column is a plus sign, so that gets multiplied by a +6. So you always want to make sure you're taking care of the signs before you do anything else. If you prefer, you can go through and find the actual product, but we'll take care of that in a second. So now, what we like to do is come up with our minors. Now our minors are the corresponding 2 by 2 determinants if you cross out the row and column that your original element is in. So I'm more visual, so I'm going to try this with highlighting. Technically I use my finger or a pencil or a pen to cross out the elements, but you can't see me do that, so I have to adjust a little bit. So if you are looking at -1, right now that third column is already highlighted. Just imagine that being crossed out. What we can do for ourselves with that -1 is we could also cross out the row it's located in. Now, if you do this, I want to make sure that you see there are leftover elements that you have not crossed out, or in our case, we haven't highlighted. So I'm going to write them out as a 2 by 2 determinant. Notice I'm using the bar notation. And so I should have 4 elements. And just so that you're clear on this, notice that they are right here. So in this particular 2 by 2 determinant, I'll write them in the same order as they appear. So I have 0, 2, -2, and 5. Okay, so now we're ready for the next element, which is a 4. And so what I'll do for myself is I will kind of keep in mind where it's located. It is in the second row. So the third column is already highlighted or crossed out. So I will cross out this second row located with the 4 in it. And then just keep in mind what your remaining elements look like. So if you kind of can play along with me, you see that we have a 2, 3. So I'll write that in there, 2, 3. And then we have a -2 and a 5. So that's our minor for the 4. Now you guessed it, we're going to move on and we're going to look at what's happening with the 6. So it's in the third row, third column. So we're going to cross out that third row and then pay attention to the elements that are left over. We now have ourselves a 2 by 2 determinant that includes the numbers 2, 3, 0, and 2. So we have expanded by minors. We're looking pretty good here. The only step needed now is we're going to have to find all 3 determinants, and then we'll multiply the results of the determinants by the corresponding element that's on the outside of it. So let's clean this up just a little bit. Keep in mind, I had a positive times negative, so that's still going to leave me with a -1. I'm going to keep that intact. When I evaluate this first minor, what I'd like to do, I'm going to write it out for you just in case. I know some of you can do a little bit mentally, but a lot of times if we take too many liberties with our mental math, it is really likely that we make a minor error and then it throws off our entire determinant. So we're going to be extremely careful here. Crossing my fingers that I don't make an error, because that would be really embarrassing, but I'll do my best for you. So if I'm going to evaluate this 2 by 2 determinant, I keep in mind that it's a product of the diagonals. So I have 0 times 5. I'll subtract off -2 times +2. Now, it could be helpful if you want to take care of this right away, just so that we're doing the math together. This is going to be 0 times 5 is 0. We're subtracting off a -4. So I'll write that in, just being really careful. I probably should use brackets for hierarchy. I like to color code so I don't get too confused. So if you want to simplify using a little bit of order of operations, you can have 0 minus a -4 is actually a +4. And then if you're happy, at this point, you can multiply. -1 times +4 is -4. Now, don't get too excited. You still have 2 more to go. So sometimes what we do is we kind of simultaneously write the steps out. Just try a few and do what you think works better for you so that you don't make any minor errors. So let's move on to the -4. That's negative times positive. So that's going to leave us with -4. That's now going to get multiplied by the determinant of this minor. So let's see. We have 2 times 5 we're going to subtract off -2 times +3. So if you'd like, we can carry that down and do the math. 2 times 5 is 10. We are going to subtract off a -6. And if we subtract off a -6, let's keep in mind we still have a -4 times. So 10 minus a -6 ends up being a +16. So if you're looking at what's the final element, in this case, 4 times 16, is that 64, I think? Yes. So remember, it's minus. So we have -64. And we are almost there. We have one more to take care of. Notice, positive times positive still gives us a +6. And if we evaluate this determinant, we're multiplying the diagonals, 2 times 2. Subtract off the product of the other diagonal, 0 times 3. And then we'll just simplify the math using orders of operation, or order of operations. So if you're taking care of the insides, multiplication comes first. 2 times 2 is 4. Subtract off. 0 times 3 is a nice 0. So really what we have left is a +6 multiplied by a 4 minus 0 is +4. So +6 times +4 leaves us with a +24. So we are almost there. We're going to find this determinant of this 3 by 3 matrix. The last thing we have to do is basically add or subtract depending on the signs that you see. So we have -4 minus 64. So that's going to give us -68. And then if we add 24, you can use your calculator, of course, if you'd like. We get a final answer of -44. So this is a very nice way where you don't have to really memorize the formula. You just kind of have to memorize a process. And it works. What's really cool is it works no matter what row or column you expand by. So if you kind of looked at the notes from the previous example, you notice we expanded, I think it was by the first row. Feel free to try expanding by the second row, see what happens. But all this needs is a little bit of practice, and I'm confident that you can do this. Feel free, do a few problems before you move on, and then we'll show you a shortcut in the next example. So I'll see you then.